welcome back. So today is the first day of the last half of the Christmas to Easter term. So I think we've gone as far as I want to go with regards to trigonometry. When we get back in the classroom, we probably have to do a little bit of mopping up to do, but I'm quite happy that we've covered enough trigonometry that we can tackle Leaving Cert exam questions. So I now want to take a look at the chapter called Area and Volume. And for the first few days, we're going to be simply just looking at area. And there's basically two different types of area questions that we can be asked. We can be asked questions about triangles and rectangles. And we can also be asked questions about circles and parts of a circle and things like that, okay? So today we're going to be concentrating on triangles and rectangles. Yeah, I suppose we should all know at this stage the difference between area and perimeter. Just in case we don't, that's measures space inside a shape, or measures space kind of sometimes of a shape. So inside or of a shape, depending on the shape we're talking about. And perimeter is all about distance around the outside. Okay, so if we were to find the perimeter of this rectangle here, and let's say that side there is 3 and that side there is 5. Can you see that? You can. Well, the perimeter would be the distance that an ant would have to walk if the ant was to walk all around the outside of the shape. So it's going to be 3 plus 5 plus another 3 plus another 5. So that's going to be 16 in total. So 3 plus 5 plus 3 plus 5 is equal to 16. And so perimeter of our rectangle is that. And our area is equal to 3 times 5, which is equal to 15. Now, perimeter, that just kind of makes sense, right? That to find the perimeter, we would add up the distances, all the individual distances that the ant would travel through. To find area, well, I suppose it kind of comes back to there being a that this is actually 3 units high and this is 5 units wide. And if each of these, let's say, was a centimeter, well, then each one of these boxes here would be 1 centimeter squared. And we should have 15 of those boxes. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So there are 15 of those 1 centimeter squares in a 3 by 5 rectangle. So that's where that formula is coming from. So that's one of the formulas. That's 2 of the formulas we will need. Okay, the area of a rectangle and the area and the perimeter of a rectangle. Okay, hopefully you're able to get this without a formula, that this just makes sense. And you will need to remember the formula for the area of a rectangle, but it shouldn't be hard to remember. Okay, you should have covered that in primary school already, so that should be easy to do. Okay, and then if I come along and I then start talking about the other thing that we're going to talk about today, which is triangles. So if I have this triangle over here, and we have to do the same thing. We have to find the area. We have to find perimeter. Now, I'm going to cheat a little with regards to perimeter. I'm going to answer that first, but I'm going to just throw in some dimensions here. So let's say this was sorry, I can't really cheat online. So I'm going to find the perimeter of a different triangle, okay? Yeah, I thought I could cheat, but I can't really cheat, okay? So let's say that that area, let's say that this distance here happens to be 8. This distance here happens to be 5. And this distance here happens to be, I don't know, let's say 6. Now, we might knock, yeah, sure, look, whatever. Now, you might just think for a second why this distance here, why he could not be less than 3. So when I was picking a number for this side here, I had to make it bigger than 3. What would it look like if it was less than 3? Yeah, if it was less than 3, well then even if this was completely flat, this line going from here wouldn't meet that, okay? So we would effectively have something that looked like this. It wouldn't actually complete the triangle if it was less than 3. So these two here need to add up to a number greater than 8. Now, perimeter. So I said I'd work out area, but I'll work out perimeter first. The perimeter is if an ant starts here and walks all the way around the triangle, he's going to walk 8 plus 5 plus 6, which is 19. So the perimeter of this triangle here is 19 centimeters. And area, so I'm going to pick a different triangle to work the area out on. Again, because I can't just throw numbers in off the top of my head. So that tells you how much prep I'm doing for these lessons. Now I'm going to give you the kind of the stereotypical introduction to this, and then we'll talk about a kind of a more complicated version. So let's say that this guy here is called A, and this guy here is H, the height of the triangle. Well, then the area is equal to 1/2 times A times H. In words, we would say area equals 1/2 the base times the perpendicular height. It's never good to be spelling things on YouTube. You can always get it wrong, but I think perpendicular is spelled correct there. 1/2 the base times the perpendicular height. So this H here, I should have explained it very explicitly. That needs to be completely the perpendicular height measured from this thing here, which we're calling the base. So in this triangle over here, can you see that? You can. Let's bring it back into frame a bit more. If I call this guy here I call this, I'm going to have to do a bit of trigonometry here myself, sorry about this. So, you know what, we'll forget about it. So the base of this triangle you might think is this line down here, but actually we're going to call that the base, and we're going to do this is the perpendicular height this time, and let's say that happens to be 5. So area is equal to 1/2 times 7 times 5, which is equal to 17.5, is it? And what's 1/2 of 35? Yeah. So that's the area of this triangle here, okay? So don't think that the base has to be somehow, that base means the bottommost side. Base just means something that we can measure perpendicularly from. Now, twists. So we always love a good twist in maths theory. What about if we had a triangle that looked a bit like this? So that's definitely a triangle, and we're given this piece of information here. We're told that that is, I don't know, 5. Where would the perpendicular height of this triangle be? So it definitely cannot be some line in here, because there's no line in here which is perpendicular to the 5 that will get us to the other vertex. So the perpendicular height of this triangle, and this used to always kind of catch me when I was in school, is the perpendicular height of this triangle is this distance here. So if we imagine this length 5 is on a straight line going forever and ever and ever in both directions, and that's where our size 5 is, and our perpendicular height is the height from this distance, not to this line segment, not to this side of a triangle, but to the line that segment or that side of a triangle is on. So it's that distance there, and this time it's going to be, I don't know, 7. Did I pick 7 already? Let's make it 9, let's say. So it's 9. So the area of this triangle, the amount of space in this triangle is 1/2 times 9. Did I go wrong there? Sorry, I did. 1/2 times 5 times 9. Okay, so that's 1/2 times the base times the perpendicular height, which is 9. Okay, so look out for those tricks that they can try and catch you out with that. That the perpendicular height doesn't have to be inside the triangle. The perpendicular height can be outside the triangle. Okay, so let's answer some questions now. So this is page 237 of old book, sorry. So this is the old book. Okay, so this is, if you're in 6th year, this is the book we always use. If you're in 5th year, this is the older book. I'll put up the page number for the new book. I'll put up the page number for the new book in the Microsoft Teams. Okay, so I'm going to answer question 6. Question 6. And I'm also going to answer question 7. Okay, so find the area of each of these parallelograms. So our first parallelogram looks something like that, and it's 14, and we're told that that distance there is 8. Now, this is where it becomes quite nice, okay? I'm going to imagine we draw a line like this. That distance there is the same as that distance there, okay? So we're asked to find the area Let's call that distance there x. So therefore that also is x. So to find the area of this parallelogram, well, it's going to be that area plus that area plus that area. So it's those three areas added together. So it's definitely going to be the area of the rectangle, which is 8 by 14. Sorry, it's not 8 by 14. 8 by 14 minus x, right? So it's only minus one of those x's. Sorry, I'll start this again. Okay, let's start again. So area equals, right, the area of this triangle here, guys, that's a half times x times 8. So that's a half the base by the perpendicular height, plus the area of this rectangle here, which is 8 times 14. I made the same mistake again. Sorry, it's not 8 times 14. It's 8. So the distance, the height is 8, but the width is only 14 minus x. So it's 14 including this x here. So just this distance from here to here, that must be 14 minus x. Plus a half times x times 8. Okay, that's good. Area equals. Okay, so it's now 4x. A half times x times 8 is 4x. Plus 8 by 14, well, that's 80 plus 32, which is 112, minus 8x plus 4x I probably should check that out in the calculator. Never trust my arithmetic. 8 multiplied by 4 is 32, plus 80 is equal to 112. Yeah. Now, looking at the algebra here, we have plus 4x minus 8x. So each of those will kill each other off, because 4x plus 4x is 8x. 8x take away 8x is just 0. So therefore area equals 112. Now, this idea that these things will kill each other off will always happen, because we can change where our x is, right? We can just change the dimensions. We will always have a rectangle with two triangles latched onto the side of it when we're talking about parallelograms. Okay, so the area on this page here, if you look at it, okay, so page 8 of our maths tables says the area is equal to A by H. So I didn't need to go through this long rigmarole here. Area is equal to A by H, which is equal to 14 times 8, which is equal to 112. Because there's this formula in our maths tables. Because the people who invented the formula spotted that these things here will always kill each other off. So there's no need to remember this formula because it's given to you in the maths tables, but if you're asked to find the area of a parallelogram, you simply multiply the base by the perpendicular height. Okay, that's quite nice. What's next now? So it's question 6, part 1. I'm going to now work out question 6, part 2. Sorry, I'm at 20 minutes already. This is very bad. Question 6, part 2. Right. And it is 9 centimeters high, 10 centimeters on that flank, and the base is 12 centimeters. And we're asked to find the area of each of these parallelograms. Well, area of a parallelogram is equal to A times H, which is equal to 12 times 9, which is equal to 12 times 9. 12 times 9 is 108, is it? So that's how we find the area of that parallelogram. We use that formula A by H. If I wanted to go the long way about it, I could do the same thing again. I could draw a vertical line down there, and I could call it X, and I could call it X up here. So let's go through that. So this is the answer here, okay? This is most definitely the answer. So everything else here is just another way of looking at it, just to verify that that formula is correct, A by H. It seems a bit too easy, doesn't it? Base by perpendicular height, but that's all we have to do. Now, right, let's go through it. So area is equal to this area here, which is equal to 1/2 times x times 9, plus the area of the rectangle, which is 12 times 9, plus the area of this triangle here, which is 1/2 times x times 9. I was going to call it 10. So that's equal to 4.5x plus 108. Oh, I made the same mistake again there, lads. Sorry. 9 minus x minus 12x minus 4.5x. I can't believe I made that mistake again. That's really bad. 3 times in a row I made it. So I might have to do this video again tomorrow, because it's really hard to learn when your teacher is constantly making the same mistake. Sorry about that, guys. So the reason why it's not 9, sorry, the reason why, oh, I really made a mistake here, lads. Yuck, 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 yuck. Sorry, guys. Right. Okay. So let's start this question again. So I'm gonna solve the area of this parallelogram, but I'm not going to use this formula. I kind of just want to make you, just kind of show you why this formula makes sense here, okay? So, right. The area of this triangle up here is 1/2 by the base, which is x, by the perpendicular height, which is 9, plus the area of this rectangle here. Now, it's definitely 9 high, but its base isn't 12, because that 12 includes this x. So its base is only 12 minus x. Okay, and then the area of this triangle over here is equal to 1/2 by x, so 1/2 the base by the perpendicular height, which is 9. So we're good to go here now. So that's 4.5x, that's 108 minus 9x plus 4.5x, and we can see the same thing happening again, that our 4.5x and our 4.5x will add together to give us the 9x that kills this guy here off. So we're left with the 108, which is what we got up here when we used the formula. Okay, I'm going to leave it there, guys, because I'm really sorry about that, making that mistake 3 times in a row. So I'll put up homework for you to do on Teams, and yeah, I'll see you again tomorrow.